All right, so we got the evaporative emission system. This is just the basic diagram of our current key-off pump module type evap system. We're not going to talk about all the different variations that we use for Toyota. There are several of them. We're going to focus on the one that you'll mostly see in the shop. All right, starting off with the evap valve. The evap valve, or sometimes called the purge VSV, vacuum switching valve. That is going to allow the system to draw those hydrocarbons that are stored in the charcoal canister into the engine. We'll talk about when we're going to do that, but that's one of our main components. Obviously, the fuel storage, the fuel tank, is where we store those hydrocarbons. That's a major component in the evap system. The pump module is a one-stop shop for components. They took various pieces and put it into one assembly. The pump module, the pressure sensor, the 20 thousandths orifice, and the canister closed or canister vent valve. The charcoal canister, kind of the heart of the system. The container for the activated charcoal, we're going to talk a little bit more about that coming up. And the ECM, the brains of the operation. Okay, now, question for everyone. When does the evap system work on the vehicle? When is it operating? Oh, I saw your lips move there, David. You're on mute.
All the time.
Ah, absolutely correct. All the time. 24/7 from the time the car is made to the time it's sent to the junkyard, that evap system works. All right? It absorbs all those hydrocarbons even when the key is off. All right, so looking inside a canister, we cut one apart here at the training center. And if you've ever seen one of these apart or blown apart, if somebody added air to the system from the shop air, maybe blow apart, it contains small little pellets, and if you zoom in on them, they actually look like little charcoal briquettes for your charcoal grill. Zoom in a little bit further with an electron microscope, which, full disclosure, we don't have one here at the training center. We got this off the internet. You look at it, it has a bunch of micro porosity to this activated charcoal. 1 gram of activated charcoal has a surface area of about 3,000 square meters. So it's kind of hard to wrap your head around the surface area of that. But if we equate it into American football fields, and the weight of the charcoal, activated charcoal in the canister, average charcoal canister has about 300 to 600 grams of charcoal in it. So if we do the math, that's about 167 to 334 American football fields surface area. So it's a lot of surface area for the hydrocarbons to stick to, surface to stick to, while we're containing it into the canister. All right, so here we have the evap application chart, and for you old heads, you know back in the early days, the darker the color, the darker the day you were having, because these things were a challenge to fix. We had the early evap systems that were only able to detect a 40 thousandths leak. Then we have the late systems, LEV 2, which is low emission vehicle 2 specification, evap system. Then we get into the key-off pump module style in 04, which is a variation of the LEV 2 with the addition of the key-off pump module. And then lastly, we have the closed fuel tank system on some of our hybrid vehicles. We're not going to be covering those today or the earlier late ones. We're just focusing on the key-off pump module style for today. All right. Okay, so let's talk about the operating pressures of the evap system. So going back to the basics, atmospheric pressure at sea level is approximately 14.7 psi, okay? 14.7 psi in millimeters of mercury is 760 millimeters of mercury. You can see the scales are much different. If you divide something up by 760, you can narrow in on very small changes easily rather than using psi. Hence the reason we use millimeters of mercury for evap diagnosis and monitoring and testing, all right? To put this into perspective, 1 psi is 51.7 millimeters of mercury, and 1 inch of vacuum is 25.4 millimeters of mercury, okay? So how do we measure this? We use the vapor pressure sensor. So it is a solid state device, right? It has 3 wires. It has VC, 5 volt reference. It has ground, and then it has an output for the pressure. The lower the pressure, the lower the voltage output. The higher the pressure, the higher the output. So now, as you guys know with circuit failures in our vehicles, if you have a short to ground, you're going to have 0 volts. If you're going to have an open circuit or a short to power, it's going to be a high voltage. So those are some tips you can think of when you're doing diagnosis. If you have those extremes, you have a problem with the electrical circuit or the sensor itself. These are some older vapor pressure sensors that we've used in the past. We no longer use these styles, but you may have seen these on the older style Evap systems. One thing to note, if you had any of these off and put them back on and switched the vacuum lines around incorrectly, you were sure to get a check engine light back on those. The new style canister pump module types, they integrate that pressure sensor into the canister pump module. It is one part and it's integral to that canister pump module. On this style canister pump module, they come with the canister. It's not a separate part that you can get. The newer stuff, we can get a separate canister pump module. We'll talk about that a little bit more here coming up. All right, so how's this system work? The Lev 2 system, all right? We're going to go through the basic operations of it during purge and then refueling, and then we'll talk about what's going on for the leak check. We'll break that all down. All right, so during purge, right, we have to have some enabling criteria, right? The engine has to be at full operating temperature. The fuel management system has to be in closed loop operation, because how much hydrocarbons do we have in the canister? We don't know. It could vary from one tank full to the other. So what we're going to do, we need to be able to measure from the engine management system, AF sensors and O2 sensors, how much additional enrichment we've gotten out of the canister. The computer is able to duty ratio the purge VSV to regulate the amount of flow out of the canister as we're operating. So there's a purge flow that we're monitoring so we don't over-enrich the engine while it's in operation. So we draw that hydrocarbons out of the canister, we get fresh air in, and we purge those hydrocarbons out into the engine, and we burn them. During refueling, right, onboard refueling, vapor recovery, that's what ORVR stands for, we're going to add fuel, right, and as the pressure increases in the tank, right, that pressure will cause what they call the refueling valve to open up, right? That pressure is going to cause that refueling valve to open up, and that additional pressure will go into the canister. The hydrocarbons will get adsorbed by that activated charcoal, and then the clean, fresh air will exit near the filler neck, okay? The canister pump module, canister vent valve operation, we're going to go into that. It is a normally open to the atmosphere valve while the key is off or it doesn't have power, okay? When the system goes into the pressure check or the leak check portion, the first thing it does, it references what is atmospheric pressure, then it goes into something called the 20 thousandths reference check. So the 20 thousandths reference check occurs as the pump pulls atmospheric air past this 20 thousandths calibrated reference orifice. Then it stores that information. It knows what the pressure looks like of a 20 thousandths leak in the system, okay? Then we're going to activate the canister closed valve. It will close off the passage to the atmosphere. It'll open up to the canister, and then the pump will run and pull the system down into a vacuum to verify that the system pressure can get below what that 20 thousandths reference orifice pressure was on that check. Here's our newer style canister pump module. Has anybody replaced one of these or seen one of these replaced? Okay, you can get it separately. It's not very hard to do. A couple clips, get in there, pull it out. It's not that difficult. It's more compact than the previous model, and the nice thing is it's replaceable separate from the canister. Okay, and it has all the same components and pieces, parts: leak detection pump, the motor, the vent valve, the reference orifice. It's the same pieces, but a more compact package. Okay, some enabling criteria for the leak check monitor, right? Just as a reminder, and I'm sure you've had customers say, hey, my car was out in the garage and I heard an electric motor running, right? The reason being, after the vehicle shut off after 5 hours, so long as the altitude is below 8,000 feet, battery voltage has to be sufficient above 10.5 volts, ignition switch is in the off position, and the engine coolant and air temp have to be between 40 degrees and 95 degrees Fahrenheit. Then that's when it'll start the monitor for the leak check. And it does that with the vehicle off, okay? And if we're to look at this monitor graphically as it's going through this whole process, we look at it like a graph of this. We look over here on the left-hand side, the first section here, we have the atmospheric reference check. Everything is off. The pump is off, the vent valve is off, and the purge VSV is in the off position. All it's doing is referencing what does atmospheric look like? What does that pressure look like right now? Next step, it's going to turn the pump on, and as you can see, it's going to draw atmospheric air past that 20 thousandths reference orifice. And what does a 20 thousandths leak look like on this car today with the current atmospheric pressure and all that? That it's going to store that information. Next, it's going to close the canister vent valve, and it's going to pull the entire system into a vacuum. Now, what it wants to do there, it's looking for that pressure to be less than that 20 thousandths reference. That way, the system knows that it doesn't have a 20 thousandths leak. After it completes that leak check, it's going to open up the purge VSV. Reason why it's opening up the purge VSV, does it have a blockage in the purge line going back up to the purge VSV, or is the purge VSV faulty? All right, we need to know if that's working properly. We want that rapid rise in pressure. Then it's going to go in and do a second 20 thousandths reference check. Verifies that, releases it back to atmosphere, then it runs the numbers and figures out, does it have a very small leak, does it have a gross leak, is the purge VSV stuck, and so forth. That's what the system is looking for. It's very important to know how the system operates to better diagnose these concerns, okay? All right, the equipment that you're gonna need, absolute must is TechStream. Gotta have TechStream. And as you guys know, you guys have been around, you just hit the automatic evap leak check, and if it fails, you know you have a leak, you got to start going diagnosing it. You can also active test any one of the VSVs if you're having a problem with one of those. So absolute must, have to have tech stream. Smoke machine. So this is the smoke machine we have here at the training center. It has 2 calibrated leaks, 40 thousandths of an inch, 20 thousandths of an inch. We can pressurize it with and without smoke. Now, how many guys have good smoke machines at their shop? Everybody have a good smoke machine? Just raise your hand if you don't. Hopefully you do. All right, so, okay, everybody does. Okay, good. One thing we found is the newer style smoke machines also have the ability to adjust the flow rate, the pressure flow rate out of the smoke machine. This can be very helpful if you have a very small leak. You can turn that flow rate down to better see the smoke. Because how many times you run into with a smoke machine, you smoke it and it's like, I can smell the gas, but I don't see the smoke, right? Happens quite a bit. And then finally, hopefully everybody has these in their special tool cabinet. These are some adapters to basically split the system up at the canister. You got one spot. It's kind of like the split half method we taught you guys in electrical class. We want to go to the easiest spot in the electrical system, split it up. Is it towards the front of the vehicle or is it towards the back of the vehicle? That's what we can do with these components. So here's a better image of them. We have the yellow hose that can go onto the canister, and we can pressurize the canister side, or we can put the brass barb into the tank corrugated line and pressurize it and kind of split the system up. And that's basically what we're going to have you do on the worksheet. Is find these adapters. Hopefully everybody has these still in their special tool inventory, and utilize these for figuring out where this leak is. Okay. Now, like I said, smoke machine, does it work all the time for finding the smoke? Not always. So one thing we found here at the training center that works really well is make a bubble mixture up. Take 2/3 cup of dish soap, take 3 tablespoons of glycerin. That's the stuff you have for your hands. You know, you get it at CVS or Walgreens. Any pharmacy or drugstore has that. Gallon of water, mix that all up, put it in a spray bottle, and put it on the suspect leak area, and you get the bubbles, all right? Cheap, down and dirty, easy way of checking for leaks, all right? Now, here is a graph of the automatic evap systems check, right? You guys have done a million of these. This is the early style, right? I'm going to break this down a little bit deeper on our next slide. Just notice our first 20 thousandths reference check. If you do the math, if you look at this graph, it's only 30 seconds long. Our newer style, we're now doing a 300 second, or 5 minutes, for the 20 thousandths reference check. So let's break this down. So we have our atmospheric reference check, right, at the beginning of the graph. That's what the computer's looking for. Then we have our 300 second, 20 thousandths of an inch reference check. We're going past that 20 thousandths orifice in the canister pump module. We'll release turn the pump off momentarily, and then we're going to put the whole evap system into a vacuum to check for leaks. That is the leak check section of the evap system check. That graph should be below the 20 thousandths reference, right? If it's not, we have a problem, all right? Then the purge VSV or evap VSV is going to release and verify that we don't have a blockage or a problem with the purge VSV. We'll go into a second 20 thousandths reference check. and then we're going to release it to atmosphere, okay? So that's the whole evap systems check, and I'm sure you guys have seen this 100 times, if not 1,000, right? All right, so this is a little bit of an eye chart, but I wanted to put this in here for a little bit of a help. It's a flow chart. It is a very good flow chart. A lot of times you get into our manuals and it's like, they have you take the front bumper off for a problem in the rear. It's like, what the heck are they doing? This is a very good flow chart for both gross leaks and very small leaks. Go through these steps and you'll nail where the problem is. Now, granted, you might have to pull the tank down and all that stuff, but it is a very good flow chart for doing the diagnosis on these. And then we have another one here. These are the 5 codes that tell you that you have a problem with the canister pump module itself for a various number of reasons. So saw these early on years ago, and it's typically some type of liquid intrusion, either fuel or water getting into the canister. So you have to take the corrugated lines off the canister, check in there, do I have liquid water or evidence of liquid water? Do I have liquid fuel or evidence of liquid fuel in there? If you don't have those, then you're gonna have to go towards the electrical side. Active test the canister pump. Does it turn on? Do you have power? Do you have ground? Are they properly oriented from the body shop that did the wiring repair or whatnot? So yeah, so this is a very good flow chart for the key-off pump module. Okay, so said we had a case study here at the training center. We bought a 2013 FRS back from the customer because it had a check engine light on for an evap leak. So, as you can probably guess, had multiple gas caps put on. It had a canister pump module put on. It had a charcoal canister put on and on and on, but they never once pressure checked it properly. So when we got the vehicle in, first thing we did, national service history. Look back at what happened to this vehicle, whose hands were on it. So right before the check engine light problem occurred, the customer had a fuel gauge issue. And guess what? They put both of the sending units in, saddle tank in this vehicle, both the sending units were put in. So it's all right, went out, hooked up the tech stream, did the automatic evap system check, fails, has a leak, hooked up the smoke machine. It smelled like somebody dumped a 5-gallon can of gasoline in the shop. You could smell gas everywhere. Couldn't see the smoke, so we put it up in the air, still couldn't see the smoke, but we noticed that there was a trail of gasoline on the right saddle that had stained the right saddle. So like, well, something's going on there. Took the back seat out, and then we pressurized the system with smoke again, and yep, you'll get it. Pressurize the system. Anybody see smoke? I have smoke on there. Take the cap off, it looked like the car's on fire. Use the bubbles, and we were able to see that we had leakage there, all right? So, what was the problem? Oh, locked up. This one? Hold on there for station identification. We actually have it here. I want to show you the root cause of this. Has anybody ever put any of these sending units in FRS? I know we don't sell that many, or an 86. All right, just a tech tip here for you. When you install these, you have to install the seal into the tank first. Then you put the sending unit in. Notice what's going on here. The lip seal is rolled. The technician put the seal and the sending unit in one assembly, and it rolled the seal over, causing the leak. Had they used the smoke machine, had they used TechStream and a systematic approach to diagnose this problem, the car wouldn't have been bought back. This is only, what, 3 years ago that we bought this back. A 2013 we bought back 3 years ago because we couldn't fix the check engine light for a leak. So just some simple things. You follow a systematic approach, you will find these leaks. Yes, they're challenging, I'm not gonna lie. I've been involved with a bunch of them, and they're a pain in the butt. You get that critter that's chewing on the top of the corrugated line, and you can't see it, you can't see the smoke, and you gotta take the tank out and all that stuff. So I've been there. So just follow the systematic approach, you'll be able to find it.